Hi and welcome back to Podcast School. This is another video podcast in the series of electronic systems, and today we're going to take a look at the Darlington pair. In electronics, the Darlington transistor, often called the Darlington pair, is a semiconductor device, and we said what a semiconductor device was in the last podcast, which combines two bipolar transistors in a single device, so that the current amplified by the first is amplified further by the second. In other words, folks, what this is a transistor whose current amplification is amplified a second time by another transistor. And you can see there's the first and there's the second. Okay, so it's two transistors back to back, in other words, or using each other to amplify a second time. A bit like you might think of, one of those megaphones that people use to amplify their voice. And if you think of that, and maybe perhaps putting, using two, so using one to amplify your voice and then putting a second around and using that one to amplify the output of the first one. That's a bit what this is like. I said there that this gives a high current gain, and we know that current gain is written down as beta or HFE, and takes less space than two discrete transistors. And you know that when I say discrete, I mean two single transistors, individual transistors in their own little can, packaged separately. Integrated packages devices are available, but still common also to use two separate transistors. In other words, you can buy one of these in one can. So imagine all of this is just all wrapped up in a can that would probably look just a bit like, or you might get a bit confused just with that and the normal transistor if you didn't realize that it was a Darlington. Okay. Or indeed you can, as I said earlier, just have them as two separate cans. So imagine two separate transistors, and you just wire them up in the way that you see there. So the emitter is directly connected to the base of the second. Okay. So let's have a little bit of history here. The Darlington configuration was first invented by this guy, Sidney Darlington, and that was back in 1953. He patented the idea of having two or three transistors on a single chip, but absolutely crucially for poor Sidney, he didn't patent the fact that you could have an arbitrary number or any number. And if he had have done, he may have covered all of modern electronics. And he was working for Bell Laboratories at the time. Okay. Now I'll just read this because I realise this text can be a little small in the especially if you're watching online. Just said that the diagram shows a typical configuration of the Darlington pair. The gain of the pair is found by multiplying the gain of the first transistor by that of the second. Okay, and if you look up the table that we had previously in the last podcast, and indeed will be in your PDF notes, you'll have noticed that the gain of the BC108 and the gain of the BFY51, if you were to multiply those together, you would get a gain of roughly about 8,000, which is huge. And of course, you have that as well as the power capabilities. Okay, so that's why we're doing this. Okay, I said there that we now have an equivalent of a transistor with a gain of 8,000 and an output current of 1 amp. Due to the higher gain, the current will now be much more sensitive to changes in light levels. Okay, so if you imagine this circuit as before with the potential divider here. The threshold voltage, and this is crucial, has changed to twice the value, and so the pair will switch on at 1.2. Remember before, the threshold voltage was about 1.6 at this point at the base. So that would have, 0.6. That was 0.6 before. So now it's twice that, it's 1.2. And I've just said that before, okay? Now, really, what you must take out of this is that the overall gain of a Darlington pair is beta 1 for the first transistor times beta 2. So that's the overall gain is that. And if you were thinking, well, what way would the current flow? These arrows are showing you the basic current flow through the transistor. So you do have base current as before flowing and getting emitted out by the emitter, but you also have two other directions that the current can flow down through the Darlington pair. Okay, that was short and sweet today. We're only about 5 minutes. This really is in conjunction with the previous podcast. So if you're listening to this and you're thinking, what is going on? Then you do need to listen to the previous podcast. And as always, if you have any questions whatsoever, don't be afraid to email me at info@podcastschool.net. And crucially, remember that the notes are available earlier in this feed. They're actually back for quite a few episodes ago, so check that you have the PDF. That's just a PDF file, so you can print that off, okay, and follow this along at the same time as you're watching the podcast. Okay, that's it for now then. Until next time, bye-bye.